Okay, today we are going to talk about 3D figures. Specifically, we're going to be working with volume and surface area. As we talk about these things, I want to make a quick note that we're going to mainly be talking about shapes that are called prisms, and we are going to focus on rectangular prisms. Even though there are other types of prisms like triangular prisms and trapezoidal prisms, there's lots of different types of prisms. If you're curious about a definition for what a prism is, or if you're curious about some of the other types of three-dimensional shapes that exist and how to find their volumes and surface areas, I encourage you to go and take a look at some of the resources that are online about those things. You might try looking up definitions and examples on Math is Fun, one of the sites that I've linked to many times throughout these lessons. And you can explore what some of those other things are. But for simplicity's sake, we're going to just focus on this for these videos. So first, if we talk about volume, I like to use an analogy of a box to think about a box. And volume is simply the space inside a 3D figure, or how much space could fit inside, or how much of something can fit inside of a 3D figure. So again, if you're thinking about a box, you might ask yourself, in a box of cereal, how much cereal can fit inside? Or when you open up a box of Legos, how many Legos actually fit inside of that box? What we're talking about there is volume, the space inside of a three-dimensional shape. And in the case of cereal, they actually will tell you the volume. That comes in ounces. They'll usually give you a measurement in ounces on a box of cereal or something like that. When we talk about surface area, sticking with the analogy to the box, we're thinking about, well, how much cardboard did it take to make up that box itself? And so our definition would be the area of all of the faces of that three-dimensional figure. So we're going to explore both of those things. Let's go ahead and start with volume today. Since we're talking about a box, I've got a box here that I've drawn, and I'm going to give that box some dimensions. It's going to be 12 inches long by 6 inches wide by 4 inches high. Now, because we are talking about measuring in inches, we also want to describe what units we're going to be counting volume in. So I've created a 1 inch by 1 inch by 1 inch unit cube. In this case, our units are going to be inches to the third power, or inches cubed. And again, you're making some tie-ins to things that we did with area. When we had area, we had units squared because there were 2 dimensions. Now we have 3 dimensions, so it's units cubed, or to the third power. I think that the best way to try to think about volume is to think about layers. The big question that we're asking right now is how many of those 1 inch by 1 inch by 1 inch cubes could we fit inside of that box? Well, we could break this down really simply by cutting this into one layer. So if I think about this box in one layer, and I think about, well, how many 1 inch by 1 inch cubes could fit inside of that one layer? Well, we already know how to do that, because that's really the same thing as finding the area of that particular shape. And that's because our height would just be 1 inch tall. But because we know that our original box was 4 inches tall, we're going to think about how many would fill up one layer and then see what we would have to do to figure out in 4 layers of that to represent those 4 inches. Well, pretty simply, I can just do some quick math there. My volume of one layer should be just 12 times 6, which is equal to 72 inches cubed. So there should be 72 blocks or cubes that would fit in the bottom layer of that box. Then we need to start thinking about this in layers. And I can build another layer on this. And in that second layer, there should also be 72. And in my third layer, there should also be 72. And in my fourth layer, there should also be 72. So that simply tells me that I can take the volume of one layer, or the volume of our base shape, and we can multiply that by how many layers there are going to be. In this case, we're going to describe this as the volume of the prism is equal to the area of the base shape. In this case, our base shape was a rectangle, and we're going to multiply that by how tall, or the height of our base shape. Again, because this was a rectangular shape, the area of our base is just length times width, and then we're going to times that by height. So if I apply that to this particular shape, I would have 72 inches cubed, and I am going to multiply that by 4 total layers. And that should give me a total of 288 inches cubed that would fit, or cubic inches that will fit inside of that box. Now, quickly, just to note, there are other types of three-dimensional shapes. The reason that we describe this formula as the area of the base times the height is because in a rectangular prism, well, the base shape is length times width times height. But we could create a triangular prism. This is kind of like a wedge of cheese or something. And you could think about this as having a different base shape. In fact, we could even rotate it to help us see that base shape a little bit better. In this case, our base shape is actually going to be a triangle. So we need to use that formula, 1/2 times base times height, and then times that by the height of the entire prism. So again, we're going to use that description when we find volume of prisms as the area of the base shape times the height. Again, we could do this with a shape like a cylinder. I'm not going to talk about how to do that, but I would simply find the area of a circle and then multiply that by the height of the circle. Finally, I wanted to show you really quickly some other three-dimensional shapes like pyramids, cones, or spheres. These are not prisms, and so they actually involve some different formulas. Again, if you're curious about those formulas or you'd like practice with those, I'm going to encourage you to do that stuff on your own. Next, let's talk about surface area. And surface area, like we said, it's how much cardboard would it take to make up that box. It's the area of all of the faces of that three-dimensional shape. So I'm going to draw a cube. And I'm going to think about how could this cube be folded flat. In fact, you could get a piece of paper right now and start playing with some scissors and maybe some folding to think about how you could fold that piece of paper and cut that piece of paper so it turned into one flat piece of paper. That piece of paper could fold into a box. In this case, we are going to break it out into a shape like this. I have the bottom of my shape right here, and then I have the sides. So this might be a side and a side and a side and a side. And lastly, we cannot forget that this also has a top here. We're going to call this a net. And in order to find the surface area, you would just need to find the area of all of the faces of each of those shapes. In this case, I would have to find the area of all 4 sides, the top and the bottom. Again, it depends a little bit on the type of prism that you use in order to find that. Well, that gives you a little bit of information about how to work with both surface area and volume. Please let me know if you have any questions. And as always, good luck.